You've typed in your URL or you've clicked a link, and now your browser's little wheels are spinning. What's going on in there? Actually, a lot. In the previous section, we looked at what a URL or web address actually is and what each part means. But what if I told you that internet equipment can't actually make sense of that in its current form? Well, part of it can, but most of the internet works using something called IP addresses, which stands for Internet Protocol Addresses. You might think of these as kind of like a phone number for each computer connected to the internet. Web addresses use standard text, which when converted to their binary form, use up quite a lot of ones and zeros. Just putting in google.com gets you this, which counts to 168 bits or 21 bytes of data. And that's for a short web address. Meanwhile, an IP address is made of 4 numbers from 0 to 255, which can be transmitted as only 4 bytes of data. Newer IP addresses are twice as long because we've started to run out of IP addresses, but that's still only 8 bytes as opposed to 21. And considering every message sent between 2 computers needs to have these addresses on it, and every computer in between those 2 computers needs to read it, it's important to keep those addresses as small as possible in order to keep transmission speeds as quick as possible. So how does something like www.google.com get translated to 172.217.2.36? Would you believe me if I told you your computer looked it up in a phone book? In order to get the IP address of a website, your computer first looks up that website's name in the Domain Name System, or DNS for short. The Domain Name System is a series of computers that hold a copy of a giant database that translates human-readable and rememberable URLs to IP addresses, which are basically just series of numbers. It's kind of like your computer is calling directory assistance before making a call. When your computer connects to the internet, it's assigned a couple of numbers by whatever equipment it's connecting into, be that a router or a modem. Among the numbers it's given is the IP address of a computer that handles DNS requests. When you click a link, it sends this link to the DNS computer, and the DNS computer sends back the IP address your computer will send the request to. I'm simplifying this whole process quite a bit, mind you, but if I didn't, we would be here a while. Now that your computer has the right numbers, it can just connect right to the other computer, right? Well, not so fast. This is where important terms like modem, router, and server come into play. When you send your request out, think of it like sending a letter. You've got some information put in the envelope. In computer terms, all of this info is put into what's called a packet. Each packet has a header, which is basically the addresses on the envelope. Now you hand that letter off to your mail carrier, who puts it in with all the other mail in their pouch. This mail carrier is actually what we would call a switch or a router. There are differences between the two, but I'm not going to cover those here. This is a computer system designed specifically to receive and distribute information within a local network. These are systems that are all connected locally with only that one system between them. You can use these systems to talk from one computer to another without ever having to connect out to the internet as a whole, which is really useful for things that are meant to stay private, like network storage drives, internal software, network printers, and so on. Switches are also connected to wireless access points, meaning that even if you're using wireless internet, wires end up involved in the process anyways. Once your message is sent to a switch, it's passed through SIPA filter to see if that site is blocked. If it's not, it's sent along to the modem, which is a special piece of equipment designed to convert signals to a form that can travel longer distances. In our case, we connect to the Internet Service Provider, or ISP, using fiber optic cable. This cable is buried underground and possesses a magical power that attracts excavators, causing occasional bits of downtime. Call before you dig, please. If the signal isn't interrupted by a rude backhoe, it makes it to the ISP, where it's reconverted from literal light to the electrical form that their switching equipment can translate. It's then sent along in a direction closer to where the destination server is located. On the way out, it's converted back from digital signals into light again. This process repeats itself several times before making its way to the destination server. This is the portion of the system that is actually what makes up what we call the Internet, because it's a network of interconnected computers designed to move information from point A to point B, though sometimes through points C, D, E, and F. These points are usually called nodes, because they just are. ISPs act as nodes because they're connected directly to other nodes using lines and equipment which are designed to carry large amounts of traffic. After bouncing from node to node, your message finally makes it to the server. A server is just another computer that holds a lot of files and is set up to serve those files to lots of different people at the same time. It's kind of like a really busy fulfillment center. The server reads your letter and sends back what you ordered in a bunch of boxes, just like Amazon. The process now works its way in reverse, with one small difference. With a few exceptions, web pages requested by users on the Williston Public School District network go through the SIPA filter, which is basically like customs. It opens up the boxes and checks for contraband. If it finds any, it removes it and blocks part or all of the page. If the package is clean, it gets sealed back up and sent to you. At that point, your browser can open the package and put the content up on your screen. And all that is happening in less than a second in most cases. It almost makes you feel guilty for complaining when a page loads slowly, doesn't it? So to recap, first, your browser asks the DNS for an IP address. Next, the DNS gives the browser the IP address. The browser uses that IP address to create a packet. Your computer sends the packet to the switch. The switch passes it through SIPA to the modem. The modem sends it to the ISP. The ISP sends it to a closer node, which sends it to another node, which sends it to another node, and the message finally makes its way to the server. The server gets the request, it sends out its response to the closest node, it goes through another node, and then back to the ISP. The ISP sends the package back through the modem passes it through SIPA to the switch passes it to your computer, and then your browser opens it like a kid opening a Christmas present. Did I mention I was simplifying? Because I am simplifying a lot. There are a lot of things I skipped entirely, including what HTTPS is, and some of the stuff that makes what you do on the web a little bit more secure. But those are topics for another day.